All right, and we are live. A warm welcome to everybody to this 20th live stream of Engineering Trainer TV. Live from the Engineering Trainer studio here in the Netherlands. I'm logging in. My name is Luuk Hennen. I'm the CEO of EngineeringTrainer.com. Today we're going to have a conversation with Sondre Luca Helgesen, who is the CEO at Stressman Engineering and one of their senior analysts. And we are going to talk about the topic of effective presentation and reporting of pipe stress results. Sondre, it's great to see you as always. It's a pleasure to have you on board of this live stream. How is your day going so far?
Oh, it's going good. It's a beautiful day here in Norway, so can't complain.
Awesome. You have a very interesting setup behind you. Let's segue into that in a minute. Now, let me also welcome everybody who is joining today. As always, make sure to join the chat. We are running this live stream both on YouTube as on LinkedIn. So make sure to join the chat, open it, and say hi. And I do, as a little bit of Kickstarter, as always, want to ask everybody who is joining to share from where in the world you are tuning in. It's also always really nice for us as host and speaker to see from where people are tuning in into these events. I also invite everybody to follow and subscribe both Engineering Trainer and Stressman Engineering on LinkedIn and on YouTube, which are two great ways to stay up to date about any of the activities from both companies. And as a final result, let me just briefly share my screen. Give me 1 second here. Yeah, I just want to highlight, we're going to talk about reporting of pipe stress analysis today. On Engineering Trainer, you will also, if you go to the total course portfolio, you will also find several courses, amongst others, several from Stressman Engineering, Introduction to Pipe Stress Engineering, Fundamentals 1 and Fundamentals 2. And we will actually also run a masterclass soon. Let me just open that one up as well real quick, which is a masterclass that we will do together with one of your colleagues, Sondre Luca, and we will run that on June 3rd. And it is about satisfying the EU Pressure Equipment Directive, the PED, in accordance to the ASME B31.3, as Nicola was involved in that process. Having said that, anybody who's joining, make sure to register for this event or to click on the link that is available in the chat or in the show notes of the videos. There you will, once you leave your email there, you will receive a 15% discount voucher that you can utilize on any of the products on engineeringtrainer.com. All right. Having said all of that, let's focus on the actual conversation. Sondre, maybe you can start by telling us from where you are joining us today.
Yeah, so today we are live from the Stressman Garage, which is where we host our Stresslorian.
That is an amazing car.
From Back to the Future. Most people know it. So it's made out of stainless steel 316, which is a steel type we use a lot in piping as well, which makes it cool. And I feel it represents the underdogs, yeah, it's a fun thing that we like to do, to go to clients and go to meetings and vendors in the car and have a good time.
Oh, you actually use it to go to business meetings?
Oh yeah, today I went to Equinor's research facility here in town. So on the hood of it, it's a decal. I cannot show it in great details right now, but it's a lot of nice dynamic problems like AIV, acoustic-induced vibrations, vortex-induced vibrations, flow-induced vibrations, multi-phase flow-induced vibrations, and so forth.
Nice.
It's an icebreaker.
Nice. When I saw it in several of your social posts. I first assumed it was just a stock photo, but then I heard you actually bought the car, and now I learned that you actually drive it, on a day-to-day basis. So that's pretty cool. If I ever have the opportunity to visit you in person in Norway, I would definitely like to jump in that car and have a quick drive.
Yeah, as long as
Um,
there's no ice on the roads, you're more than welcome.
yeah, I just heard you. When we were prepping this session, you parked it in the garage, and the sound was pretty impressive as well. I have to
Yeah, the
say.
sound is impressive. The speed is not.
um, all right, Sondre, you have quite a long track record in the pipe stress discipline. To my knowledge, well over 20 years. Have led several endeavors. Have founded you have founded Stressman Engineering. Um, Maybe you can kick things off a little bit on how you got involved in the pipe stress discipline in the first place.
Of course. So ever since I was a little kid, I loved computer games, for example, and even more fun than playing the games to manipulate them. You know, what happens if I manipulate the gravity and so forth. So then I started thinking about, okay, it'd be cool to actually work with this stuff. So in the beginning, I wanted to be like a computer engineer, maybe one engineer that was making games. But then I figured out, okay, we can use these tools for simulations. So I really dug into that during the university when I was doing my bachelor degree, and then but it was a bit by chance as well. You know, like life always is that when I started working my first job, they asked, "Do you want to be a pipe stress engineer or a piping designer?" I was like,
Yeah.
I don't know the difference, to be honest with you guys. And they looked at my what do you call it, the grades I had from the bachelor degree, and they were like, "Yeah, you like math, you like physics." It's like, yeah, that's totally true. Then pipe stress. If you don't like it, we can move you over to the designers. You know.
Right.
So a little bit by coincidence, but I also been all my life in piping. My father was actually a plumber. My great grandfather as well, and I think it's like I'm the fourth generation working with piping.
Oh,
Uh,
really?
but I'm working more on the theoretical side. They were more in the field
Yeah.
doing the work, you know. So
All right. Thanks for sharing, Sondre. We've also got plenty of people dropping in a quick message in the chat. Just for you also to be up to date. Sondre, we've got people joining from Paris, from Belgium, Houston, Aberdeen, Italy. So as always, quite a mixed international crowd, which is pretty cool. So when we were discussing the topic of today and in preparations of this talk, Sondre, like it became clear that we really wanted to share your experience on how to present a clear and convincing and also actionable let's say report and communication. Maybe you can kick things off by sharing your view on why we do a pipe stress analysis in the first place.
of course, it should be pretty obvious, of course, why we do pipe stress, but it's good. I feel sometimes just to think about it. Why are we actually doing the stuff? Because we get so used to it. And of course, the main priority number one is safety. We want these piping systems to be safe for the people around them. It's not only the people working in the plants, right? It's also like here in Porsgrunn, we have a lot of heavy industry in the middle of town.
Yeah.
And there's a lot of bad stuff going through those pipes. So we don't want them to leak, for example. That could be potentially really hazardous for the entire population of our town.
Yeah.
So that's the primary objective. Keep them safe, you know. And then the second part, it's not only humans that matter. Environment matter as well. So if you have a leak, if you have a pipe that is bursting or something like that, you could have very toxic chemicals uh, that goes into the environment, and you have bad environmental damage. So, and of course, cost. The owner would need to repair his process plant or his offshore oil rig or whatever it is. That can be really expensive, and failure costs a lot. But also poor designs, they cost. Like for example, if you have too much flexibility in your piping system, then maybe a pressure drop is more than it needs to be. So you have an
Yeah.
operational cost over the lifetime of the facility. So yeah.
Yeah. And I remember when I've been involved with engineering trainer for a while, so I haven't done actual pipe stress and the reporting of it for a few years. Like one of the things, I mean, why we do a pipe stress analysis is very high over, for more from a strategic point of view. I remember, especially as a junior, I was quite. I kept on going too much into detail in these reports.
Yeah.
Is that something you see often? Like, what are your thoughts on that?
Yeah, very often we see that happen all the time. I'll talk a little bit more about it a little bit later because I feel that's a very good subject because um, too much information is overflowing the reader. So and that's about the fourth point on this PowerPoint as well. Is like building the trust. You build the trust between you and your colleagues, between you and the client that hired you to do that pipe stress analysis, and also the stakeholders, the end users here. When it comes down to reporting, there is some pitfalls. Being a junior engineer, you want to include not only juniors. Being an engineer, you want to include as much details you can, which is in many ways a really good thing. But it could be information overload. So if there is a lot of information, maybe it's better to put them into appendices so that the technical readers can dig into the details they would like to do and focus on basically. And another thing that we see when people are reporting is what's the message here? What are you trying to tell the reader? So it's more like a philosophical question, I would say, but you need to put yourself into the shoes of the reader, and you need to make that message clear. I've seen pipe stress reports that doesn't conclude on anything. It's just reporting a bunch of numbers. There is no statement in there saying that this system is safe to operate, for example, or everything is in accordance with the codes and regulations. Of course, me as a pipe stress engineer would see that it is, but it's not obvious to every reader of the report. And yeah.
Yeah, I also remember it came to like a little bit as a shock to me at the time is when I found out that most of the people that receive the report don't actually read it in detail. I felt I had to report everything. Everybody has to know everything, but you can't. Yeah, you can't expect everybody to read it. Very busy people. That was something that was I remember a big learning point for me at the time.
Exactly. And exactly what you're talking about, the audience mismatch. You don't match with the audience. And I also had that sad experience that you talked about there, that I realized that my reports are probably not going to be read by anybody in full detail. But that's the way it is. But if something goes wrong, it's very good to have the details in there so that you can backtrace what was actually performed of analysis before this thing was built, or if it was modified, the piping system was modified, for example. Okay, how did they consider assumptions and so forth? So
Yeah.
and that's also with you should have enough technical depth, but also you should think about strategical impact and how do you, again, what do you want to communicate to the reader here? So you want to emphasize something, do that in the report and do it in the summary on the front of the report, for example.
Yeah. Feel free to continue, Sondre.
So as we already talked about, too much data, too little space. The reports, they can become literally thousands of pages. It all depends on what you want in your report. But I believe that the main report, of course, there is exceptions to every rule that we talk about. But I believe that the main report, if you can keep it around 20, 25 pages for the main report, where you condense the information, you use illustrations and so forth, at least my personal preference, that's about the length that I see is very feasible. Sometimes 30, 35 pages as well. But I also read reports without any appendices that was several hundred pages long, and then you lose track of what you're really trying to capture.
Oh wow.
So yeah, and then in the report itself, just you should have technical accuracy, but also with a clear communication.
Like you mentioned here, competing expectations from different stakeholders. Can you elaborate on that perhaps a little bit? Like, who are the stakeholders? Who do you write the report for typically in the first place?
So you have your colleagues who probably will do a review of your report, like an internal review, to make sure you didn't make any mistakes and so forth. They need to know all the technical details, and that should be given in the report, of course. And then you got maybe your leader in the company, or maybe there's a project leader from the client who are more interested. Okay, do we have a go or no go for this piping system? Is it rooted with sufficiently enough expansion? Do we have all pass on all the flanges, equipment, and so forth?
Yeah.
And they don't care about the details, to be honest, and they should not, because they got other things to do as well. So then it's to be clear on what you have done in a more compressed format. So yeah, and then you have the end users as well. It's about the same thing as with the leaders and so forth. They just need to see that something was done, a short summary, and that you have included the topics that is the most essential to you.
Yeah, yeah. I mean, you have a variety of items discussed here. Maybe you can elaborate on those for a second before moving on.
So when you're writing up a report, explain your assumptions. Don't assume that your reader understands everything. Of course, you need to find a balancing point here as well. But what is your boundaries? Explain it. Also put some words to it. And the load case combinations. How did you think when you put them together? Material specifications, of course. Keep all of that so it's easy to read in the report. And then also show your methods. If there is like long calculation, maybe those fit better into a appendice instead of having the entire method shown in the main report itself, but maybe have the primary or the starting point equations and a table of what you concluded on in the appendix in the report. And of course, visuals. Use visuals instead of huge data dumps in the report. Use visuals. Data dumps you can put in the appendix. And then summarize your conclusions and also tell the reader, what does this mean? Okay, you have 80% utilization of the pipe stresses according to beta 1.3, for example.
Yeah.
Write it explicitly. This means that the code is you're in code compliance. So yeah.
There's some cases where you have only maybe 8 load cases.
Mm-hmm.
Some cases where you have hundreds.
Mm-hmm.
In the latter, like how do you go about it? Do you explain them in a lot of detail? I mean, people do have to understand what the design choices you make, I guess.
Yeah, the train of thought I think is important. Then you can write some text around it as well. That okay, case for example 1 to 12 is operating cases without wind loads or accelerations. And then from 13, if you have a lot of cases, I'm talking about now, if you have 8 cases, for example, then a good description on each side of the cases could be nice to have, of course, and a short text that's explaining what they're using the different cases for, or that could even also be in a table. If you have, like we have a project now, we had 840 cases, I think.
Oh wow!
And it starts to become a little bit more confusing.
Yeah.
So I was checking that report, and you had to start in the end of the case combinations because they're all referring to each other, and this was to minimize the envelope of conservatism in this case. Of course, there was simpler ways to get less than 800 and something cases, but we were pushing the limits here of the equipment. And well, to be fair, we didn't push it that much either because there was some assumptions in here that was overly conservative, but we still had to consider them as real challenges. So at least we had to break it down to make sure that we didn't combine all the deflections. So this was structural deflections combined with thermal expansions. So we didn't want to combine them, just slap them on top of each other and get away with maybe 50 cases, 60 cases, because then we would need to design much more complex expansion joints in this case. So here we condensed. We didn't condense. We made them. We expanded basically the cases to have a lot of cases to reduce conservatism, and then we had a longer introductory text about what are we doing and what are we doing where and what are we using the various cases for, and how are we considering the loads on equipment, how are we considering the expansion stress ranges, for example, and so forth. So it's a very detailed explanation that maybe took half a page in front there. And of course, again, this is not every time you need it. Maybe you have a project specification that states that use these load cases.
Right.
Then you might just refer, as long as you concur that these load cases cover your problems or your challenges, then just use it and refer to it. But in many cases, when we are working on projects, we have special cases, so we need to make the load case setup by ourselves, and then explaining it. And also here we had descriptive text for each of the case downward, just to have for ourselves' sake as well, to understand what was going on. But it was a repetitive pattern that we could use in this mayhem of cases.
But I mean, for 800, that must have taken like pages in the report.
Yeah.
You wouldn't put that in the main report, or maybe you do. Like, I don't know. What are your thoughts?
Yeah, well, it depends on how the report will be looking. As you said, this was pages. So here we moved it to the appendix, and we described the method in the report, and we kind of had from load case 1 to 50, for example. That's just combinations of thermal, hot, cold combinations, and so forth. And then we have the next one where we are adding structural deflections due to wind and the wind load itself. And then we wrote them as ranges just to explain what is.
Exactly. Categories. Hey, we've got one comment from Pankaj. Pankaj, thanks for sharing. He mentioned the ASME B31.3 Appendix S also covers reporting, like what exactly to report. So obviously there's like the list there.
Yeah.
Pankaj, you also mentioned, first of all, thanks for sharing your thoughts and experience. You also mentioned, Pankaj, in the UK, our reports are reviewed by the client and third parties like DNV and Lloyd's. It is needed for the PED, the Pressure Equipment Directive, DOC, the Declaration of Conformity, which is the European legislation. Did you ever run into those situations, Sondre, where you had like notified bodies, third party notified bodies going over it as well?
I would say for our reports, 30-40% of our reports are sent to notified bodies, maybe even more. I don't have a track of it. We just cross our fingers. We never hear from them. That means that everything was good. And it was good that you mentioned Appendix S. And there is also here in Norway, we got DNV, the Norwegian Veritas, as he was mentioning as well. And they got, I just want to mention it, they got a recommended practice called DNV RP D101, which is a very nice starting point, especially for junior engineer, but also as a senior, just going in there. And then that's DNV writing up a lot about their expectations to pipe stress analysis. And there is a chapter there as well on reporting. What should be in a report? I don't concur with all of what is in there. There is some chapters I think you can smash together to one chapter, for example. I like to have conclusions and results in the same chapter. I start off with the conclusions in the beginning, and then I back it up with the results in that same chapter. I know some people have results chapter, and then conclusion is basically referring to the results chapter and saying, okay, based on this stress level shown in chapter this and that, we are in compliance. Yeah.
Yeah. Do they? I can imagine that they are typically more stringent readers, given
Yes.
that they have to put their stamp on it. Is that true? Or it's just me guessing.
I would say so. Yes. And their focus might not be the same as your focus when you're doing the pipe stress analysis as well. And sometimes it's more pro forma issues. Other times it's really good technical discussions, but that varies a lot from project to project, I would say.
Yeah.
And notified bodies also humans, so it depends on which person you meet in the notified body and what their focus area would be.
Yeah. Hey, you already moved to the next slide. Maybe you can elaborate a little bit, and we continue
Yeah,
from
I
there.
just pull up another one. It's a very simple one, and this is probably natural to a lot of the people watching right now, but it's just to be aware. And it's like if you have a lot of data, this is just copy pasted from a sagging hogging analysis. The data is important to present somewhere in the report, but keep that for the appendices. But plot them in the main report. If there is something that could be visually plotted, I always like that. It's simple, sit down. It gives a more intuitive way of reading reports.
Yeah. Yeah. I think you. Yeah. Feel free to continue, Sondre.
Yeah. So, and also when you're talking about reporting, it's not only about showing the results, but also, well, this is basically a results because you start at one point and you end somewhere else. And again, this all depends on projects. If you got 50 modules you're calculating and it's a mass-produced project, so to say, you might not do this. But say in this case, there was a lot of special issues. As you can see, the before analysis didn't have any expansion bellows. But we had to slap on, as you can see, a lot of expansion bellows here to make this system design work with respect to the allowable loads on the equipment primarily. And showing design before and after in this case gives also the reader like an instant insight to, okay, there has been challenges and it looked like this was how it was sold, especially for a client, because they remember the first design because it was their design. And then after we performed our analysis, of course, in between here has been several iterations between us and the client and discussions. And we always are, if we see something doesn't pass, we don't just send them a report, sorry, didn't pass, We always then are proactive and go back to them and say, hey, we see that we have too much loads on the equipment. Very often it's thermal expansion. We need more flexibility. And then we discuss in detail how to include that flexibility into our analysis. And then it's nice, I feel, as a history of the project to show it before and after.
Yeah, it also builds on the point you made about visuals. It's a very, I mean, this is a very clear representation of the results. Yeah.
Yeah, and also visualize. Again, I'm saying the same thing over and over, I feel, but visualize instead of just listing. Very often, that goes for our report sometimes. So they just list the natural frequency of a system. But when it comes down to flow-induced vibrations, for example, it's also interesting to see the mode. How is the mode actually shaking? And that we can take out of CSER2 and probably most other softwares out there as well. Some kind of plot to show. Then you see which pipe is shaking. Of course, you could put a line number next to the case one and the hertz.
Yeah.
But in this case, you can also see in what area the line is shaking. And again, that's just communicating to the reader, okay, at 2.29 hertz or 28 hertz there and 2.37 hertz, this is the modes you will see. And then if they are experienced, okay, they will take a look at it. Yeah, but we don't see any harmonic loads that will resonate with these frequencies, for example.
Yeah.
And they continue.
Yeah.
And another thing is to make sure that after you've done your analysis, it's very important that your client actually understand what they should do, and not only them, but especially the people making this system. It might be somebody else. For example, this is just an example, but this goes for everything. If you have pipe supports with gaps, for example, and this is very important that you have a specific gap at a special support, maybe it's a blast support, and you need to have a specific gap there. Then how do you communicate? And I feel that put it on the summary page on front of your report. Important that the expansion joints are, in this case, expansion joints are installed in the correct orientation. And also explain a bit about it. You don't need too much text about it, but explain a bit about it in the report itself.
Yeah. Yeah. Would you mention like to what level of detail would you mention these things on the isometrical drawings, for example, like the degrees of freedom of a bellow, the exact gaps? I mean, obviously, there's a lot of information that you can easily put on the isometrical drawings, but you want the reader who hits the summary at the top, at the start, to immediately be aware, what to pay attention to.
Yeah. So it all depends again on communication with the people who get the report here, because very often we are focused on stress. We don't do the full design of the system. So we don't make the ISOs. We make pipe stress ISOs or node markups on our client's ISOs, for example. And in there we will use pointers and explain that, okay, the tie rods should be orientated. If you take the two tie rods, for example, that one should be orientated. The two tie rods should be on the vertical axis, for example, or the horizontal one. It's like basically two choices here. So yeah.
Yeah. How do you how do you make sure often, when one puts in a report, it's like it's in the report, so you should have read it. You should, like, how do you know what to emphasize and where do you emphasize it? Like especially these things, which are the core of let's say the analysis and the results, and are critical to the design.
Yeah.
I mean, you in a PowerPoint you would put like a big exclamation mark, a red arrow to it,
triangle, warning sign, or something. Like be aware. We don't do it that dramatically in our reports, though. Again, the summary page, including these kind of special things, if there is something that is special to the report itself. Come back a little bit more to the summary page a bit later, but put it there. And I would also put it in the conclusion and results chapter, maybe even in the beginning of that chapter, because I know how I read reports. I always read the summary and I jump to the end, to the end of the report, and I read the conclusions there. I read the results. I look at the loads and flange leakage checks and these kind of things. That's where I'm starting, and then I might start reading. It depends what the purpose of me reading the report is. If it's just to get an overview, to understand what people are doing, maybe that's almost it. If I need to get a much more detail into it, then of course I will read all the chapters. But is there something on the front page or the conclusion that capture my eyes?
Yeah. So I think most people, will actually do that they jump from the beginning summary then to the back conclusions.
Yeah.
So those what you're saying is those are the places to really highlight items that are, the important ones also, that are noted on the isometrics. I mean segueing into, you just mentioned like, how do you read a pipe stress report? Let's elaborate on that a little bit. So what is, like, what are, let's say, the thought process you go over if you receive a pipe stress report, maybe from a junior or from anybody outside of the company, to evaluate?
So if it's inside of our company and I'm the checker, as we call it here, we have one project responsible, and then we have a checker. Maybe we have an executor in there or several executors, all depending on how big the project is. But let's say I'm the checker. That means that I'm gonna review the report. And during a project here in Stressman, the checker shall always be about up to speed on the project. Doesn't need to know all the little details at all time, but it should be enough that if the project responsible gets sick or something, it should be possible to continue the work with a minimum impact for our clients. But let's say I'm getting a pipe stress report to check. I would take a look. If you have a 3D model, if you have something visual to look at, I would just look at that and imagine, if I know the temperatures, pressures, loads, and so forth. I always like to visualize it inside of my head. How would the thermal expansion look like? How would the sustain plot look like? How would occasional loads impact on this? And then again, I would open the report, start reading the summary, jumping to the conclusion and the results, and then read through it. And what I'm looking for, if it's an external report that we got because we are working on something and we needed some information from a different person, or maybe our clients is like, yeah, can you check this report for us? I don't have all that insights when I start on it, but then also I read the summary, the conclusion, and then you start to get a feeling on the level of detail. You get a feeling on the quality of the work very quickly if you're experienced. You've seen a lot of analysis. And then it's the gut feeling, and a lot of people is like, yeah, you're an engineer, you can't just go by gut feeling. It's like, no, it's not only gut feeling, because I believe our gut feeling is just the summary of the summation, of all of our experiences as engineers and life itself. So if something feels wrong, sometimes it is. Sometimes it could be good. Maybe I misunderstood something because they reported a bit differently from us. But yeah.
Yeah, but that's an interesting point you raise, is not to just read it and go with the storyline provided by the writer. But what I hear you say is to first take some time to develop a little bit of gut feeling, or let's say engineering judgment of the system, and then have that challenged by the report, basically. I think that's a very interesting approach.
I really like it when the report doesn't concur with what I think is going to happen, because then you shall learn something new, or the report was wrong. It's usually one out of two,
So what are typical questions you would ask to challenge the writer then, if there's a mismatch with your gut feeling, for example, and what you read in the report?
I would just start open questions. Maybe there's not too much details about the spring hangers, for example. I might ask them, okay, how did you evaluate the spring hangers? Just start like a very open question, and then you see how they respond. And it's like might be mumbling and a little bit evasive and so on. Then you understand, okay, here we need to dig a lot deeper. If they come up with a great explanation right away, then you understand, okay, this person knows what he's doing. Okay, let's go and take a look at something else. And also sometimes I just tell them that I don't understand how these results can end up like this, because in my head, I was thinking they will be different, and then have an open discussion about it as well. And then it's like, oh yeah, but you see over here, we model the structures, stiffness into the model, for example, and that pipe support is fairly flexible, but still it's okay. And you get the more nuances. And then it might be okay, but you didn't write about this in the report, for example. You added the flexibility of the pipe support, totally fine. But you did not write it that clearly in the report that you included it, for example. Maybe I could see it in the input echo file.
Let's see, like we've got a couple comments coming in, Sondre. Maybe it's good to segue into those. So we've got, first of all, Pankaj to share the, let's say, several sections from the SME B2.3 Appendix S. And one of the comments also in the chat was, that those are results from the examples, but those are, could be used as a benchmark for what should be in the results. In the report. We've got one question from Harshal. Thanks, Harshal, for sharing. He raises the point. Well, let me first read up the question. How about the aspect that sometimes people make reports not to convey the message, but to document the things in order to preserve the details that cannot be accessed without, the analysis software and the knowledge or for the future. I've seen those reports as well, where you have like very limited of descriptive information and a lot of numbers and just factual statements on the model, etc. What is your thoughts on that? Yeah.
Well, first of all, to preserve it for the future, I would say always print out the input echo. Slap it on. Yeah, it takes a lot of pages. It fills up a lot of pages. But with the input echo, I've been reading input echo since the 60s when you use this deck of cards, the punch cards, and you have the printout is like 10, 15 meters long. And you just start on the top and you just read it. And we were able to replicate that system, even though there was no software to read this back in there. Not even if we didn't have a scanner that big to do it, even. So, but going through line by line, and if you're an experienced engineer, doesn't matter if it's Triflex, Caesar 2, Auto Pipe, K Pipe, Roar 2, and Windpipe and whatnot. It's like there is a system. It's just to see the system and then start getting modeling on it. So we have, call it, resurrected several pipe stress analysis based on this approach, which is why I feel input echo is so important. And also, let's say that the example somebody put in the stiffness of a support, and then I'm like, okay, that support over there, I'm curious about that support, and then I can read all the details that the stress analyst put into that support. So input echo is something that I hold sacred, that should be with every report. We've seen some other companies didn't want to give that away because they feel it's like the negative, like a photo negative. It's their own property. I think that is
really
information. Yeah, I met companies like that because I was asking, how did you model the pumps, for example? Did you include the expansion of the pump casing and so on? And it's like, yeah, you get vague questions, but if you had input echo, you can just go in there and check yourself directly. So that's why I really like the input echo. It's a simple format. Yeah, it's tedious, not the most fun thing to read through. So with respect to reporting, that's usually Appendix A in our reports.
Do you write a report in order to document what you did, or to highlight a certain point or potential change? I've seen reports where it is really like boring. Maybe some boring is good, but just like almost like the input echo in some wordings, where there weren't really any highlights or anything. Like, how do you write it? Do you write it for just, let's say, that you have it documented, or actually to make points?
I don't like just giving out a report you slap on a front page, and as you say, you data dump the analysis behind the front page. Maybe you have half a page of text or something. That was a little bit too general. Let's say if we had several of those projects where you have a lot of pipe stress analysis reports, and they're going to say almost all the same things. So you don't want to spend time on copy pasting the same text, and then report number one had to be updated because notified body gave you a comment didn't really change much on your analysis, maybe didn't even impact the analysis, it was just comment to wording, for example. And then suddenly you need to copy this wording to 60 other reports and revise everything. And then suddenly you're spending hours you didn't need to spend. So having a master report with the method of how you've been thinking, if there is something that's not in aligned with your method or philosophy, then you write that in explicit terms in that specific report where you stray off the path, so to say. For example, we've been doing a lot of that was more FEA though, but that was more piping components. We had hundreds of piping components. They needed solid FEA, ASME 8, Division 3, and a small comment to the reports would mean a lot of work for us, even though the comments might not change that much or anything. So then we had a master document, and then we documented everything. And then suddenly it was one component that was failing by 4 or 5% or something. But then we switched method to do a elastic plastic analysis, for example. Is that just purely elastic? And then we were inside the acceptance criteria again. But then you only had to make that change into one report, not write about it in every report, for example. So
yeah. We've got a couple just general notes coming from the audience, which I would like to share. Louis Bolivar shares. First of all, thanks for sharing, Louis. Suggestion: make sure to write equipment tags on plots, which I think is a fair statement.
yeah.
Definitely truth.
Very good.
He also mentioned try avoiding assumptions in the report unless anybody can validate them. I mean that
there is both pros and cons there. I feel assumption is an assumption. If you validate it, it's not an assumption anymore. That's my take on it. But if the assumptions are on the conservative side, and in many cases we put in assumptions that are not totally validated, but we know also that what we are doing is conservative. For example, we are doing sometimes hydrogen-induced stress cracking in accordance with DNV-RP F112. And there is some factors in there. If you don't know any better, you can assume some factors, and you know we are conservative. And then if you're having problem to get compliance, then you can start digging into setting up like a detailed FEA, for example, to verify that your real factor is lower than the factor that you chose.
Another point that was raised in the chat, which I think is interesting, is equipment loads. I think in one of the examples just now, you mentioned that you did a redesign of a system because of high equipment loads, and you added in several bellows and other solutions. It's not always the case that the equipment check, the load check, is part of the pipe stress report. Maybe the load cases, the loads are just reported for the static department to discuss. Do you see it happen often, and how do you go about this, that you include like the NOS load check, like WRC or any other route in this pipe stress report?
If it's pressure vessels, for example, and as you mentioned, WRC 107, 297, then for those, you can do calculations. As we say in Stressman, we're more than happy to do it, but we must also be a bit aware of who's the responsibility. If we're doing an FEA, for example, of a nozzle, using Nozzle Pro or using ANSYS or doing something, and we say it's okay, but the vendor of the equipment didn't confirm it, well, what's the responsibility afterwards, for example? That's one thing. Very often we do it just for internal sake, and we see that this nozzle has a lot of capacity. Let's ask the equipment supplier to do a recheck with our loads, for example. In some cases, we are, as you mentioned, we might not have an allowable load. We just are requested to report them. It doesn't happen that often, but it happened 2 weeks ago. and we just report the loads. We feel they're fairly low, and then what is fairly low? Some vendors say 0 Newton on my nozzle, and I was like, yeah, dream on. But we felt like we pushed it as low as we could go for that system within the reasonable limits, and then we passed them on to the supplier, and they confirmed them. Normally, you don't know if you could have higher loads. You could have a more well-designed piping system, for example. It's just the downside of not having the allowable loads in the first place.
Yeah. Another question I would like to raise from Mandeep. Thanks, Mandeep, for sharing. Sondre, how do you see the usage of FEA in pipe stress analysis? I mean, as Mandeep writes, it sounds perfect to incorporate high-level FEA, but we found fewer users willing to use FEA on their projects.
Oh, FEA, yeah.
With B31J providing better SIFs and flexibility factors, does that change the industry usage of FEA you feel? And do you see, this is me adding to the question, do you see that combination of FEA being incorporated in pipe stress reports a lot? So let me just break it down. How do you see the usage of FEA in pipe stress analysis? Do you see it being used more often now that or less now that we have the B31J available in the space? And how do you combine that with reports?
I feel, well, it depends. Depending on the size of your components, your thicknesses, and so forth. We've been doing a lot of FEA with respect to high pressures. For example, if you are in Chapter 9 of Beta 1.3, there is requirements to do more comprehensive fatigue analysis, for example. So in those cases, you might not get away from doing FEA. But if you're talking about Chapter 2, normal thicknesses, let's say Schedule 40, for example, I would try to go with B31J as much as possible. It has a much more comprehensive set of equations than compared to the old Appendix D of Beta 1.3. And also there you have the stiffness of the T's and so forth. And you should not get too big of a difference between FEA and B31J, to my understanding. I haven't compared too many tests against each other. I did some, also some SSIs I checked, and they were almost spot on. When I ran a elastic plastic collapse check, and I checked them up with Tony Paulin's data. So FEA, I love using FEA, but it can also be used too much, I believe. It depends on the purpose, I would say. If you have a very special case, if your fitting is not a standard fitting, of course you need to approve it somehow, then FEA is a superb way to do it. Yeah.
All right. Thanks for sharing. We've got two more comments I want to address, and I mean, let's then head back into the slides to do, let's say, the closure statement. As we're running well close to an hour, Sondre. First of all, Louis Bolivar, thanks for sharing that page of the DMV. I think you also mentioned the DMV RPD 101.
Yes, that is
just now. So Louis added like page 21 is the one to go to. We also have a question from Ignacio, who addresses the challenge when it comes to the version of the isometrics. Ignacio writes, when working with stress isometrics, most engineering firm I know use isometrics from design programs like SP3D or E3D or AutoCAD Plant. However, it's quite possible, that this pipe routing in those often big models are not the exact one built or built in the pipe stress calculation. It may be similar, but there might be not exactly the same. I think this addresses that challenge. I think I've experienced it. Would be interested to hear your thoughts.
Yeah.
That you're doing the pipe stress analysis based on a certain version, but as you're doing it, there might be some small changes in the design going on as well. Then you need to go back to do the design analysis again. Like, how do you experience that interface with piping design and these elaborate software models where the entire routing is modeled versus the smaller ones in Caesar 2 or in any pipe stress software?
So there's several points here, but suddenly you always get these surprises now and then. It's like, oh, but there's a pipe, there's a branch over there. It's like, never was there before. It's like, oh no, we added it 2 months ago, and nobody communicated it, for example.
Right.
In such cases, it would be nice. So I know Ignacio a little bit as well. So they're working on this stress isometric software as well, which is very nice, where you can export the models and you can map them on top of other models in, I think it's in Navisworks. And then you can see, do you have the right routing or are you off somewhere? You can also click on the support, you get out the loads and so forth, which is a good way to transfer data from piping to structural. But there is one challenge we face a lot here in Norway when we have DNV, and back to that DNV RPD 101, it states explicitly that you have to make your stress isometrics based on the software that had built the model originally. So, for example, exporting from Caesar 2 would disqualify you in this case, which means that your client, if you're only doing the stress, let's say, as in Stressman, we are getting isometrics from our clients, then we will need them to actually make us the isometrics. We might help them to put on the node numbers, arrows, these kind of things.
Oh, really?
But they have to make it because it's in their system, and then we know we have the latest edition of it, and we mark it up on top of there. Or usually we do markups if there's something we need to change that's already been discussed, and we know they changed it in accordance to what we needed. And then they send us the final, and they put into the template, the tables where you can put loads and so forth. I'm not a big fan of those, by the way, but if you're going to do it according to DNV RPD 101, that's the way to do it. And you will not get your pipe stress report qualified if it was a pipe stress isometric made from Caesar 2, for example.
All right, I didn't know that.
Yeah. Software that was not the original software of the design.
Yeah, interesting.
It's easy to get burned there.
Yeah, but I can imagine the struggle with having the client support that.
From my understanding, the idea here, why do they want to do this, is that you have a set of drawings from the design software, and then you can take your input echo and you can hold them you can print them out. Don't do that; it's a waste of what do you call it, of paper. But I know people do that. So they print out the ISOs, they print out the input echo, and then they start comparing. Okay, node 10 is I don't know, a fixed point. It might be let's say it's a fixed point, and then from node 10 to node 20, there is a flange that is 100 millimeter long with a weight of this much, and then you can go through the input echo and compare it with the pipe stress isometric. And if you have a match between the two, you have the correct model in your Caesar 2 or AutoPipe or whatever system that you use in.
Wow, that does sound elaborate.
Ways to check it better, but that's the purpose behind this check.
Yeah. All right. Just some. Let me select 2 or 3 more, Sondre, before we wrap it up. I think there's some nice input and conversation going on in the chat. One point raised is on pump nozzles. It's a little bit out of topic, but if nozzles are failing in rotating equipments, and we could not be able to mitigate the nozzle allowables, What will be your action if rotating equipment vendor is not accepting higher allowables? Like the question is basically like, what room do you have in your experience? Maybe you can share some thoughts. It's not
Yeah.
that much related to reporting
Yeah,
on
it's
nozzle
more
loads
how to
of
solve
equipment
this. Yeah.
of pumps.
Of course, we all been there.
Yeah.
And usually it's in the middle of the night. You tried 100 million iterations and you don't get a pass. And you really try. And maybe it's only one direction. Maybe it's even a shear force that you feel that, yeah, this is not a problem. This is not generating that much of a load on the pump. And then you're really trying. And then in the end, you wrap it up and you send it to your pump vendor and you ask them for, please, can you accept these loads? And they like, nope, without even lifting a
Yeah.
finger. It's very frustrating.
Yeah. Yeah.
All
They
been
have
there.
zero incentive to do so, of course. Yeah.
Exactly. And what happens then is, okay, can we look into, for example, flexibilities? I don't like messing around with gaps, for example, because that we are not making Swiss watches here. We are making piping systems. So playing around with 1.7 millimeter gap doesn't make sense, for example. Of course, looking at your supports near the pump, of course, you probably did that. Maybe looking into the stiffness of the supports. Maybe that gives you a bit more flexibility, and that reduces your thermal loading on the pump. So basically, you have to get within. If you don't get within, of course, you have to tell. It depends on how your project is set up. Maybe your company is also doing the design, and you're delivering directly to the end user. You could ask for a technical deviation on it. But also, I've seen pumps fail due to too high loading, for example. So it's a real problem. They don't fail instantly, but because the pump housing, they can handle the loads, but the shaft going from the motor to the pump will be
Yeah.
distorted, and that rotates with a lot of RPMs, and over time that will cause a fatigue failure, or it might be the bearings, for example, or it could be, yeah. So it's more about not distorting the pump, and then we into another discussion as well. Should occasional loads be a part of the pump check? Of course, it depends on the loads, but I believe no. Should we use operating, or should we use design when checking rotating equipment? I strongly believe we should use operating, because that's what the equipment will see 99.9% of the time. So even though you go above, that might be totally fine. So then these kind of discussions kicks in. I see a lot of our clients already specify use the operating temperature when checking the equipment loads on rotating.
Yeah, that makes sense. Thanks for sharing your experience on pump loads. As you said, like we've all been there. It's a challenge. Another challenge is raised by Nikola Drazenovic. Thanks, Nikola, for sharing. Sondre, how do you deal with stress analysis on brownfield type projects where you have to take into consideration existing piping systems for which you don't always have appropriate data in terms of isometric equipment, isometric drawings, equipment drawings, and you still need to qualify your piping system to which you are connecting. Have you ever run into that situation, and how
Many
did you
times.
deal with it?
Many times we got those kind of jobs. Okay, we're just gonna make a small modification. That's always how it's pitched. And then you look into it, it's like, yeah, but you're gonna put an equal T on an existing piping system, and you're gonna impose some kind of loading on the existing system. So then, how do you know that what you're doing to the existing system is okay or not? That's kind of the biggest difficulty to evaluate. And as you say, you might not have. I've been to oil rigs, old ones. I went out there and went into the high pressure mud pump room, looking around. It's like 1, 2, 3 pumps, okay, but my drawings is only showing 2 pumps, for example.
Exactly.
And then you look up at the roof. There is all the piping, and nah, let's throw those papers away and start sketching them up again. So then literally starting to sketch up what's there. to make a pipe stress model that you can use, even though you're not going to touch those pipes in the roof, for example, but you're going to connect something on the next level to this pipe work, and at least having like 3 to 4 pipe supports in various directions, to have some kind of limitation to where your impact will stop impacting the existing system. And this is something we see over and over again. Sometimes we run sensitivity studies as well, just playing a little bit with we try to make sure that what we are putting onto the new system is minimal loading, and then you might not know all about the details and so on, as it was mentioned here. So you see, okay, if you're conservative, we assume that all the expansion of this pipe is going straight up. What would happen to our pipe and the existing piping? And then we assume that the opposite thing might happen, doing some envelopes just to evaluate that what we're doing is making it better. We had that case with back to the pump discussion we just had. Exactly that thing. It was we're adding a bypass. Our clients had used the sign loads, and we were trying and scratching our heads. We could not get within the allowable. And then I came up with the idea, let's analyze what was there before. I don't know why I didn't think about it, right? And I analyzed it, and then it was even worse. It was even higher utilized without our bypass connected to it. So basically, our system made the pump loading better, and we used that as an argument. But you've been running these pumps, and they wanted to use the sign temperature, not operating. Switching to operating, we went within the allowable. But as we said, do this comparison. It's better now than before, and it's been in operation for quite a while. So that could be a judgment call as well. We do that several times on offshore rigs where it's limited with information, and we're just going to insert, for example, a T, and then we're going to have some equipment connected to it. So not really going to impose much loading or stiffness change to the overall system, running the system part that we can see and we have data on. Then we cut it out and put in the T, and we say, okay, results changed a percentage, 1%, 2%, and then it's like, yeah, this is not going to change drastically the behavior of the piping system.
Interesting. I hear you say several things, and one bottom line I also hear is you have to get really very practical if you're dealing with systems for which of course for which you don't have the right drawings and connect into.
It is always interesting with those systems, but also they have so many uncertainties to them. So, but I was saying, just walking the line, using a laser, for example, to measure the lengths and so on. If you can see the support types, you can get pretty much data from doing that. Even though if it's not spot on to the millimeter, that's no problem when you're doing the analysis. That will be a bigger problem when you're doing design, for example. It has to fit in the end. But from the purpose of doing a recalculation, if it's off by 10, 20 millimeters, well, that will not make a change there.
We've got another few questions dropping in, but I do want to end the conversation, bring it to a conclusion. We've got a couple questions coming in on bellows. Like, I think we'll have to dedicate a dedicated
episode for that
section on bellows and go into detail. But that is definitely sounds like an interesting topic for a follow-up session. As a simple closure, or maybe not so simple, but as a closure question. I mean, artificial intelligence, big topic at the moment, a lot of developments. Do you, what is your take on using artificial intelligence when it comes to reporting? Just to segue to the topic of today's session. And then maybe you can also share a little bit on if you see utilization already for AI outside of reporting, but for, the pipe stress work in general. Can you comment on that, like AI in combination with reporting and other than reporting?
Of course, I have tons of ideas and things I want to do, but what stops us the most is the sensitive information in our reports. So we signed NDA, non-disclosure agreements, with all of our clients. So you're not going to share their information, and sharing that with, for example, ChatGPT Pro or something like that, you don't have full control anymore of your information. So just uploading a pipe stress report there, or uploading your data there and start building reports there, well, I would like to do that. I was thinking just making some mock-ups just for my own sake to test it out. So still, that's something that we're looking at. So, for example, having a large language model that was trained internally on a server that doesn't have access to the outside world, so to say, could be something in the future. But being more practical at this time. And then also one thing I want to mention is that with AI, it's still the human that should be in control of it. So you should know what you're looking for. You should know why are you using it. You should be very clear, and it's always you that carry the responsibility. You cannot complain about the AI or the computer told me so. It's like, yeah, but then you're not a good enough engineer. I've been doing some tests with non-sensitive information. For example, load case buildups. They're basically just letters and references and so on. So they don't share. When you share one of those, you don't share any sensitive information about the project.
Anonymous information. Yeah.
Exactly. So in that case, as I talked about earlier, explain in your report how you built your load cases with words. I've really liked that, because then with words, it's easier for the reader to understand the train of thoughts. And if you take that chapter that you wrote, put it together, and you just, if there is some direct information about the project name or something that is sensitive, you just delete it. And then you copy this into ChatGPT, and you copy your load case combinations in there, and you do you ask it, okay, now you're the pipe stress engineer. I would like you to review my load case setup. That was working surprisingly well when I tested out. It spotted some minor things, like, for example, I've been copy pasting, and I could see that, or I didn't see that, but then it detected, for example, it was written a description wind east, for example, the wind load was coming from the east, while in the load case description itself, it was saying wind 2, for example. Maybe wind 2 came from the north. And then it was identifying these kind of basic mistakes. But in that report, we had many load cases as well. So I already did a screening of what I did. This was before I was passing it over to our internal check. So I was using it as an extra check on my work. So that's one way. Also been data dumping, for example, deflections that had to be different combinations of them, and just then as well in the report it was written a text about it, how we combined the deflections, and then I copied that text. I copied the raw data, because that's also no sensitive information. You cannot link it up to anything. It's just numbers. And I told it to make this type of tables, like organize the tables like this and that, because that was the way I organized the tables, simplify them in our report. And then I took what ChatGPT gave me in the end, copied it into Excel. I took our report, the table from our real report, put it into Excel. I took cell this minus cell that 0, because there should be 0, because if there is a change there, if it's any number than 0, that means that either I made a mistake or ChatGPT made a mistake of the combinations. And then also, sometimes I identify that the way I think I'm writing sounds very logical inside my head usually, but then when it reads it, it might get another perspective. And in that case, it's also valuable, because then you see, okay, it misunderstood what I wrote. Could it be due to, because I'm a Norwegian guy, so I don't speak and write perfectly English? And then I usually see it's my fault that I wrote it not consistently enough or explicitly enough. for others to truly understand it. So then you also get a check of your language if it starts to report something else than what you thought. So yeah.
Yeah, that's interesting. Like you basically say that, like you sometimes use it as like a partner to do a sanity check, but
Yeah.
you wouldn't do a hey, here's my report, write a executive summary, please,
I
type
would like to try
approach.
to do that, but I cannot do it right now
Yeah, safety.
because of
Yeah,
the NDAs and so on.
yeah,
But sometimes for not for a summary on the front page, but let's say the introduction chapter. If it's a client of us, we go to their website, we collect some data from there, and the project might be public, so we go in there and see what they're writing about the project, and then we copy that one and condense it down to a few lines. It's very efficient. I'm not a text writer. I'm an engineer. I like numbers. I don't like to write
yeah,
texts.
yeah. All right, I think that's a nice closing statement as well.
Yeah.
Engineers like to focus on the numbers and the actual analysis and not just the writing.
Mhm.
Um, I mean, it's been a great conversation, Sondre. I think we've been able to address also several questions from the audience, which is always nice.
Yeah.
And thank you for your time. I do want to emphasize everybody watching, check out the courses of Stressman Engineering on engineeringtrainer.com. Make sure to leave your email in the link that is both in the chat of this event as in the show notes, which will mean that you will receive a nice discount voucher if you ever want to join anything on engineeringtrainer.com. And again, Sondre, thanks for making the time
Yes,
and
thank you
sharing your experience.
for having me, and we drifted a little bit off topic, I feel, in some of our discussions, but that's always the fun part, when we're having these kind of
Exactly.
talks.
Exactly. That's part of the fun, and totally fine. And again, as long as we've been able to provide some value in addressing some of these questions, which I think we've been able to. Sondre, have a great day. I know the weather in Norway is pretty nice these days.
It is.
So I hope you'll be able to enjoy it. And for
Yeah.
everybody tuning in remotely, thanks for joining. And hope we'll stay in touch. Make sure to follow both Stressman Engineering as Engineering Trainer on YouTube and LinkedIn. Have a great day, everybody.
All right. Cheers. Take care. Bye bye.